Welcome to the project demonstration of hybrid power generation system using solar, wind and piezo. So here we are going to utilize the non-renewable source like piezoelectric plates as well as renewable sources like solar and wind. So we are using the three sources along with the grid to store this energy which is generating from the sources. So to store the energy we are making use of 12 volt 1 amp battery pack. So here the main features is whenever the available of current or voltage is available from the sources, that will be stored into this battery pack, and then whenever we want to utilize that stored energy, then we can utilize that with the help of this inverter. So here in this project the main stages are power generation from the three sources, and whenever the no source is getting voltage to charge a battery pack, there we are going to use a grid power supply to the transformer to charge this battery pack. So once a battery is charged, whenever we want to utilize the power, then with the help of this inverting circuit we can utilize that to the 230 volts AC load. So here this is consists of two stages. One is an inverter and there is a step up transformer. So the inverter will invert the 12 volts AC, so 12 volts DC to 12 volts of AC, and that will be step up to the 230 volts of AC, and that will be connected to this load directly. Coming to the ratings, so we are using 12 volt 20 watts DC generator which will generate up to 14 volts to charge this battery pack. So here this consists of a dynamo along with gearbox and turbine. So whenever this turbine rotates 1000 rotations per minute, this gearbox will be convert that to the 2400 rotations per minute, and that the generator will generate the voltage of 14.5 volts maximum, and that is input to this battery pack through this charging circuit. So this is a charging circuit for the wind. So every charging circuit is commonly connected with the components. So you can see the 4 diodes. So these 4 diodes will acting as a rectifier, and next filter. Whenever the rectifier is done, then there will be chances of ripples will be generated, and that will be neutralized by this filter, and output of this filter is given as input to this LED indication along with the 2 diodes through the battery. So these 2 diodes will act as a unidirectional current flow, means whenever the battery is getting fully charged, these 2 diodes will block the current flow from the battery to these sources, either from the piezo or wind or solar panel or transformer. And here coming to these 4 diodes, so when we are providing the AC, for example, there we mentioned T by S, transformer or solar. So whenever the sunlight is not available during the night time, if you want to charge a battery pack, just connect this T at this T slots and on the power supply to this transformer, so which will step down the 230 volts AC to 12 volts of AC. Now these 4 diodes will act as a rectifier to convert this particular AC to pulsating DC, and this filter will remove the pulses and provide as a pure DC, and after this 2 diodes same as usually connected to the battery pack as a unidirectional current flow. Now when we are using the AC inputs, these diodes will acting as a rectifier, that is full wave rectifier, there is a full bridge rectifier here. Now when we connect the solar panel, right, so connect this solar panel here. So when we connect the solar panel, then these 4 diodes will act as a polarity corrector, means if we connect the solar panel directions in reverse polarity, then there may be chances of getting damage to the battery pack if we don't use these 4 diodes. So if reverse polarity was corrected, then the battery or solar panel may get damaged. In order to protect that, we are making use of these 4 diodes which will acting as a polarity corrector. Remaining 2 diodes are same as usually working of unidirectional current flow in the remaining 3 charging circuits. And coming to the wind, so here in the wind charging circuits, these 4 diodes will acting as a same polarity corrector as whenever the wind rotates in clockwise direction, we can see the light indication on the wind, and the same way in counterclockwise we can see the light indication. So that is the purpose of 4 diodes on the charging circuit of wind generator. Same for the piezo also, as it is going to use, we are going to get the voltage of AC signals from this piezoelectric plates. So that is the purpose of this 3 charging circuits to charge a battery pack. So once the battery is charging, then it will be converted into the AC initially and then to the step up transformer. Directly we can utilize that to the AC load, as it is the stages of these 2 MOSFETs will convert the DC power supply of 12 volts 1 amp to AC of 12 volts 1 amp, and that will be step up to the 230 volts of 1 amp directly to the load. We can utilize that for in household applications. And mainly ratings are, as we discussed, 12 volts 20 watts and there's a wind power generation, and 12 volts 5 watts for the solar panel. Though we are using the 12 volt solar panel, but we can get up to maximum of 17.5 volts, which is sufficient to charge a battery pack here. As you can see that, so the V out maximum power is voltage of 17.4 and the power is 5 volts. 5 watts we are going to get from this solar panel. And piezo is we are using this is only demonstration normal purpose of showing, and which can provide up to the 12 volts and same 5 watts we are going to get that. So we place the piezo plates into these two cardboards, and in that we are using the 9 piezo plates. In that 1, 2, 3 are in series. Total these 3 sections are in parallel. So we will get of maximum voltage, maximum current to charging of this battery pack. So battery pack, as we discussed, 12 volt 1 amp. So here we are using a 3, we can see the 3 batteries. So in that 4 volt 1 amp, 4 volt 1 amp, 4 volt 1 amp, totally 12 volt 1 amp DC output. And coming to the transformer, we are using 230 volts to 12 volts of AC of 1 amp transformer. We are using to charging of this battery pack, right? And finally, once again, demonstration of this one. So when we place the solar panel under the sunlight, we can see the more light intensity which will coming out from this respective charging circuits. Thank you.